Assalamualaikum and good day to my final year project supervisor, Dr. Zvrayati, my co-supervisor, Mr. Shazwan, and also my respectful panel, Dr. Irani Azlin. My name is Muhammad Uzrashidin bin Ahmad Sharani, and today I would like to present my FYP 1 proposal titled The Effect of Windswept Angle on the Aerodynamics Characteristics of UiTM's Hawkeye UAV Aircraft. UiTM's Hawkeye UAV aircraft is an unconventional aircraft that comes with fixed and forward swept wing. This type of forward swept angle, theoretically known with several advantages toward aerodynamics performance, especially in terms of better maneuverability and stability. And obtaining a significant wind swept angle is compulsory to get a better lift, drag, and moment coefficient. However, UiTM Hawkeye has no prior aerodynamics characteristic studies when it was invented. Thus, this research aims to obtain the aerodynamic characteristic of UiTM's Hawkeye UAV aircraft with varies of wing swept angle. Computational fluid dynamics software and sysfluent will be used to simulate the dynamic characteristic of Hawkeye. In order to get correct results, the settings on the software during pre-processing, equation solving simulation, and post-processing must be correct. Next is the problem statement. In this section, I will explain why I choose this title. Firstly, there is no prior study that have been run on the wing swept angle of this aircraft. The compressibility of air during high speed, which produce the formation of shock waves on the wing surface, can be delayed based on the sweep of the wing. Thus, the correct angle need to be found. The wing swept angle of UiTM Hawkeye is -8 degree, which is not in the common range of wing swept angle of any forward swept aircraft, which is between -20 degree to -40 degree. And lastly, the proper wing swept angle, where the best aerodynamics performance located, is undetermined. Thus, the correct angle need to be found. These are the objectives of this study. Firstly, to obtain the aerodynamic forces of UiTM's Hawkeye UAV between wing swept angle at -25 degree, -30 degree, and -35 degree. Second, to visualize the lift, drag, and moment coefficient. And lastly, to visualize a better aspiration results on the surface than the former design. On this study, we will only be focusing on several scopes to avoid too many variables, which will make this study more complicated. Firstly, the wingspan will be fixed for all simulation, and only 3 numbers of angle sample will be run, which are at -25 degree, -30 degree, and -35 degree, with the usage of NACA 2415 FOI only. The speed also will be limited to Mach 0.11 at average of velocity 35 meter per second during the test. For the limitations, I found that lack of previous studies, journal, or papers on forward swept UAV have been done before by research centers due to its unconventional design. I also aware that this study is a full-scale CFD analysis, which will take a longer time than a scaled model analysis. For literature review, I divided this section into 3 parts. Firstly, I have done the research on advantages and disadvantages of forward swept wing aircraft. Second, I studied the possible method for this project. And lastly, I have done research on the previous study on the forward swept wing. As I stated before, the forward swept wing are better in maneuverability than conventional aircraft. This is due to all swept wing has the properties that their aftmost part will stall first. Thus, the stall for forward swept wing will occur on the wing's root, which leaves the aileron unbothered. Unlike conventional aircraft, the stall will first occur on the wing's tip, which makes the aircraft unstable and need external device support. This will allow any UAV with a forward swept wing configuration to fly at a low speed with great maneuverability. For the CFD software, I will use the ANSYS Fluent due to its accuracy and reliable results. Some of the features are the full model scale 1:1 can be used. It has unlimited test space, and the fluid flow visualization can be generated by using post-CFD. Turbulence model that will be used is Palat-Almaraz SA to compute the Reynolds average Navier-Stokes runs equation. This is because many applications of SA turbulence model used in aerospace provides an economical computations of boundary layer in external aerodynamics and give good results in most cases. There are several previous studies on forward swept wing UAV aircraft. However, I will only show 3 here due to lack of information on the others. The previous study are included 3 UAV aircraft built by 3 different universities. First, the UiTM Hawkeye from UiTM Malaysia. Second, Archangel UAV by North Carolina State University, and the modified E-Flight AS3 Extra, a study from Harvard University. The maximum CL by Hawkeye shows the poorest performance due to the lack of studies during its invention. This is the methodology of my study. So far, I have done the first and second step, which is review journals and papers on previous study. Second, redraw Hawkeye aircraft wing width 25, 30 and 35 degree. So next, I will continue my studies with the next steps, which is run the simulation of the wing model without attached to the aircraft body using ANSYS Fluent. And at this step, I have to done it until I success. If I not success, I have to run again this step. If I success at this last step, I will continue my studies with run the simulation of the wing model will attach to the aircraft body using ANSYS Fluent. The same step will be used. I have to run it until I success, and after I success at this step, the data I will analyze and get the result and do discussion on the results. That's all. To run this simulation, the design needs to be altered specifically at the leading angle part. The design should include the usage of NACA 2415 effort. So at the end of the study, the expected results are the aerodynamic characteristics are better and show higher performance than the previous study due to the usage of new airfoil and better sweep angle. The results will be compared between each angle, and the one with the best performance will be chosen. The result will be compared to the previous result to see the improvement in terms of performance. That's all. This is my project planning Gantt chart. As you can see, I have planned this Gantt chart for 2 semesters, which is for FYP1 and FYP2. The yellow one is the planning, and the blue one is the actual. As you can see, I have put the redraw design at the bottom, at the below of proposal presentation. This is because I know that the design will be readjust after this, even I have done the I have redraw it before this. And the final presentation will be on the FYP2 and thesis writing. Yes. So this is the FYP1 milestones. FYP1 milestones is I can say it is the journey of my FYP. So I have done it, and I also can track which one is completed or in progress. So as you can see, the redraw designs, I put it in progress because I expected it to be readjusted as I stated before. That's all from me. Thank you for listening. Assalamualaikum.